the first speaker of our session is Associate Professor Dong Guo from Chongqing University of Technology. So please, it's online, right? Yeah. 你们放吧，播放吧。顾老师能听到吗？
听到了，张教授。
好，请你线上那个发表吧，好吧？谢谢啊。
OK。
15分钟发表，还有5分钟呢，我们用那个现场就是问答，好吧
？OK。
谢谢顾老师啊。So each presenter spend 50 minutes for the talk, and remaining 5 minutes for the questions and answers. Okay.
Okay, everyone. Good afternoon. My name is Guo Dong from Chongqing University of Technology, and I'm very glad to share our research work about the DCT rattle. My research topic is about the experimental study of effect of torsional vibration attenuation methods for driveline with DCT. Okay, here's my contents. First, the background. Torsional vibration of transmission system may cause typical unwedged problems such as rattle and clock. And under the pre-selected gear strategy, the rattle problem of dual clutch transmission is more serious. For example, the top picture shows without pre-selected gear, and the bottom left shows the fourth gear with pre-selected with the third gear. You see, with the pre-selected gear strategy, the gear rattle phenomenon shows more serious. And we have make a literature review in the open literature. There are many experimental results of vibration attenuation measures. For example, first type is CTD, clutch torsion damper. And the second one is dual mass flywheel, EMF. And third is clutch micro slip control, CMSC. And the final one is about centrifugal pendulum vibration absorber, CPV. And we have make some shortcoming conclusion. In the open literature, there is no comprehensive comparison about the aforementioned four methods. Secondly, most of the previous research is about manual transmission. Transmission like DCT, especially with pre-selected gear strategy, there's only a few research about such kind of transmission. So, we have done the four methods in the same DCT transmission. Here is the basic parameters of the vehicle. This is SUV with 7 gear ratio DCT. There is a structure scheme. But for the 4 types of attenuation methods like CTD, this is the actual picture of CTD and DMF and the CPVA and the clutch micro slip control. We have done the testing in the same DCT of the 4 methods. Before that, we have make tables about the advantages and disadvantages of the 4 methods. The DMF can only work on narrowband frequency, and CMSC may decrease the transmission efficiency. CPVA has a good torsion shock absorber performance, but it's a complex structure at a high cost. Here is experiment results. This is an experiment condition. This is we done it in a road testing, road NVH testing, and in Figure 4 here is sensors, rotary speed sensors installation. Just like we use 4 speed sensors located in primary flywheel, secondary flywheel, the fourth gear, and the first gear. Yeah. First result is about the CTD, because it's a basic parameter of a CTD is in the table. Some of the parameter values are from engineering experience, and the conclusion can be said that with the increase of rotational speed, is input shaft rotational speed, the angular acceleration of the input shaft decrease, but the value is always above the 600 radius per square seconds. You can see always above this line. And there may be a strong torsional vibration because the input shaft angular acceleration is always above this value. The second testing result is of DMF. Also, the parameter you can find in this table. And the results shows that the angular acceleration amplitude of the input shaft does not show a per minute peak like the CTD. And it's always below the 600 radius per square seconds, you can see. And use the DMF may decrease the rattle possibility. The third one is about the clutch micro slip control. The left finger, finger 7, is about the blue line is a driving disc rotation speed. The red line is the driven disc rotation speed. You can see the speed differs. The average speed difference is almost keeps the same in 20 RPM, which means our control strategy or our control system works well. Then we do some other testing, like we verified the sleep amount, and also in CTD and DMF types of attenuation methods. In picture 8, you can see the green dashed line. This is a DMF with 16 RPM sleep control. So with the green dashed line shows the best performance, absorption performance, and the red line is just CTD with CMSC control. The fourthly, here is about the centrifugal pendulum vibration absorber. CPVA is a basic parameter for the CPVA. The testing results shows that below 18,000 RPM, the input shaft angular acceleration amplitude is always below 100. Well, after 18,000 RPM, the input shaft angular acceleration amplitude gradually increase. Maybe this is because the nonlinear characteristics of the CPA. Always CPA show a softened nonlinear characteristics after some high certain speed. Like this, after the speed 18,000 RPM, the input shaft angular angular acceleration will increase. Okay. Finally, we have make a comparison of the four attenuation methods. Figure 10 shows another useful testing result. Figure 10 shows the CTD vs DMF. The dashed lines is DMF. You can see when we use DMF, the DMF may increase the perimeter flywheel torsional vibration. Okay. In figure 11, we have make a comparison of different methods together. The red line, the black line is CTD, only CTD, and the red line is CTD vs CMSC, and the dash black line is DMF, and the red dash line is DMF is CMSC, and the red dash line is DMF is CPVA. Because the DMF with CPVA has a best vibration absorption ability. Okay, here is the summary of these two fingers. The DMF will increase the angular acceleration of the primary flywheel. And if we use clutch micro slip control, the torsional shock absorption performance can be improved. And DMF with CPVA has the best torsional absorption performance. Here is my summary. The DMF will increase the angular acceleration of the primary flywheel, but the clutch microcontrol at the CPV has no significant such effect. Through the road test, the DMF shows a better performance than CTD. Then, the torsional shock absorption performance can be improved while we use clutch micro slip control. But the clutch micro slip control may decrease the system efficiency. Likewise, when we use DMF with CPVA, that can improve the vehicle's NVH performance, but only once the rotation speed is below 18,000 RPM. Okay, that's my presentation. Thank you very much.
Okay, thank you, Professor Guo, for your excellent presentation. So now please, audience, do you have any questions? Please. 郭教授啊，大家好像还有一点没有提问，我提个问题好吧？你把你的那个slide， 就是你的 PPT slide 到那个图11，我想有点问题问一下。
好的。赵教授，您看到了吗？
我没看到你的图，你的那个 PPT 的那个应该是要图11吧？
对，现在看到了吗？
这个你要用个共享屏幕，可能，要不然你就放你的 PPT 放到那个大概倒数第3张。你们那边没法做是吧？对。
现在呢？
还是看不到。
嗯。
OK， 那我问这个问题吧，就是
好的。
OK， 对，这是你看啊，你的那个比较好的隔震效果啊，一个是那个绿色的线和那个绿色的点线和红色点线，但是呢，在这个速度高的sorry, I should speak English. So in the high-speed range, say above 2,500, then you will see the green line. The angular acceleration is actually higher than the the red the dot line, right? So
Yes, yes.
And also you can see the green line from 2000 RPM, the angular acceleration actually is increasing together with the rotating speed. Now,
Yes.
what is the reason behind that? Is that somehow, to my understanding, is something associated with your rotating speed? Now, is there any excitation, external excitation associated with this rotating speed? So, Professor Guo, do you understand my question? Do you want me to repeat or? 这样，我用中文讲，就是
Okay, I hear. Because the network is not working. Okay. So the rotation speed is about like 27. Yes, the green dash line shows yes is larger than the red dash line. Maybe it's related with nonlinear dynamics or the nonlinear characteristics of the CPA. We have do some simulation. Yes, we have do
dynamics. So what component is nonlinear here?
CPA.
Okay.
Central tandem. We have done some simulation work before and find that nonlinear phenomenon. So in the testing, we only show the good results below the 18 RPM. But yes, our simulation work doesn't find that phenomenon.
Okay, good. Thank you. Any other
Thank you, Professor John. Thank you.
Okay. Another question then. In terms of the cost of the two dual mass flywheels,
yes.
Which one is more expensive? Like you have the red and green lines.
Yes, the DMF with CPVA. We can apply CPA to DMF,
Yeah.
and but it's the
high cost. Okay.
High cost. Now we have to ongoing research work is about CTD or single flywheel with CPA. That will lower the cost.
Okay, good. Good. Thank you.
Thank you.
Okay. So thank you very much, Professor Guo, and we have to move on and to the next presenter. Okay, thank you, speaker.
Thank you, Professor Zhang Dong. Thank you.
Okay.